Right. Um, I just want to say thank you all for joining our space. This is also my first time hosting a space, so I'm not really going to be doing a lot. The purpose of this space is just for us to engage with the community. Um, we recently won the parachain auction, and honestly, I just want to say that the support has been overwhelming, and that we really really appreciate everyone showing up for the crowd loan. And we want you to know that we've been building Hyperbridge for the past, I want to say, 16 to 18 months. And it's been, I'm not gonna lie, it's been a grind, trying to do something that's really never been done before. It's also exciting, it's thrilling for sure, but also not very easy. And to know that we have the backing of the community, we have the backing of, I would say the Polkadot core ecosystem, and the Polkadot agents, it really, really strengthens our resolve, in a way, and just gives us that energy to keep the fight going. And so, yeah, just thought we would do a small AMA, discuss our roadmap, discuss how the community can get involved, and what is our long-term vision for Hyperbridge in general. And I have my co-founder on the call, David. It's probably going to be the first time that any of you interact with David. But yeah, David's basically the 10x, or even better, 10 to the power of 10 engineer behind the scenes. He's responsible for a lot of the work that's actually going on, working on Hyperbridge, working on our relay, doing protocol design sessions at night. He basically never sleeps. Sometimes I might like call it quits and leave the lab for a bit. Then I might forget something and come back and it's like 1 a.m. and this he's still like grinding in the background. So just like going to let David introduce himself as well.
Yeah, hi guys. Yeah, I'm excited to be part of this space. Like it's been really exciting, like building Hyperbridge and seeing the community support. And yeah, I'm very uh, appreciative of the support we got throughout the crowd loan. It was really amazing. So thanks, guys. Looking forward to like hearing from you and um, seeing what you like expect of the product and the contributions you hope to make. Yeah.
Yeah, for sure, for sure. So I mean, we can basically get started on some of the alpha, on kind of what we have planned. So as we already know, Hyperbridge is live on testnet. If you haven't tried it, please go try it today. Gateway.hyperbridge.network, and you can do token transfers across all of the networks that Hyperbridge is connected to. You can kind of see all of the different steps, all of the different transactions involved in your cross-chain messaging. And we designed it to be completely transparent, right? We want you to know where your funds are. This is of the most important to us. I mean, we don't need to show this on the front end, but all of the work we did on the back end is sort of rendered useless if we don't communicate what's happening, right? And this is also, you know, um, in line with our ethos of full transparency and full trustlessness, so that you don't have to trust us for any reason. So our plan, at mainnet, is to launch Gateway as sort of the first application on Hyperbridge. Hyperbridge is pretty useless on its own. You can think of Hyperbridge basically as an ISP, as a networking provider. If there's nothing to be sent over the network, then as you can imagine, this network is not very useful. Um, and so, of course, token transfers are one of the most important applications of cross-chain interoperability, and we want to allow people to be able to securely send their tokens from one chain to the other. Our first tokens that will be available for transfer on Gateway would be the DOT token. So we believe that the DOT token is kind of useless at the moment, unfortunately. I know a lot of the DOT people in the house will kind of agree. There's so much liquidity elsewhere, unfortunately, just not in our ecosystem. And the DOT token is in our opinion, a blue chip asset, right? It's received, I mean, I don't think it has received a no action letter from the SEC, but at least the SEC hasn't brought it up in any of its securities litigations. And as such, we think that the DOT token actually could be used for lending, lending on actually other chains that have much more mature lending protocols and have locked up a lot more liquidity. It's the case that there's just not a lot of liquidity within the Polkadot ecosystem to do dot lending, and so we believe that being able to have the DOT token be used for lending across all of the chains that we're connected to will bring greater utility for DOT holders and DOT token holders. We're also looking at also allowing for lending of liquid staked DOT as well. So if you're staking DOT maybe through Bifrost or any of the other liquid staking protocols in the ecosystem, you should also be able to take that liquid state DOT and use it on a lending protocol. Also, we hope to see DOT being listed on, say, Uniswap or PancakeSwap, all of these Uniswap forks, basically. And this, I think, will allow people to trustlessly access the DOT token, right? Because at the moment, it's the case that you can only buy the DOT token on an exchange. This, in my opinion, it's not that great. We want the DOT token to basically proliferate across multi-chain and have anyone anywhere be able to buy the DOT token, or even better, be able to buy the staked DOT token and sort of receive staking rewards through that means. So the DOT token will be the first token that will be available to be bridged on Hyperbridge. It's because of the way that Hyperbridge is designed, and the way that you need to pay for messaging with stablecoins. When you're bridging DOT, unfortunately, because there's no stablecoins on the relay chain, you would have to basically self-relay your own DOT bridge and transaction. This is because otherwise we kind of run into the same issue that Snowbridge has, which is where now you have to pay for fees in DOT, and that's just not a great user experience in general. Imagine if we said fine, you could pay fees in DOT, but the DOT token maybe goes down, and the fees that you had provided is just no longer sufficient for request delivery. Relayers would ignore your request, and that's just how it is. We prioritize the profitability of running a relayer. We don't want at any point our relayers to be losing money. And so this is kind of why we've chosen that it's just probably better for people to self-relay their DOT bridging, to all these different chains. And if you have gas fees to cover your transaction, your bridge transaction on any of the chains we support, then you will be able to bridge your own DOT back and forth, right? And you can entirely control this process. We showed off how, if it's the case that you can't bridge your tokens, you always get them back. And so that will be the first thing. Then the next thing would be KSM as well, bringing some love to the KSM people. I think KSM is being pretty much neglected, but it's the I'd say it's the more cutting edge version of DOT, and that's so we need to treat it that way, right? So we will also reactivate our parachain on the Kusama network and allow people to through that bridge their KSM to all of the networks to support. You can also use it in lending. Not even sure if there's any liquidity for KSM in its own network, but I'm sure it will find liquidity in the multi-chain. So once we have, we're able to secure some TVL through this, we have constant daily transactions through this, then we can start to onboard tokens from other networks, right? We can now start to allow parachains, for instance, to bring in liquidity from any of our connected networks, whether that's the L2s, whether that's Binance, whether that's Ethereum itself. I think that it's bridging is always a two-way thing, right? Of course, I'm sure a lot of us would only want to see liquidity flow into the ecosystem, but it's what's really happening is that it's going to be trade, right? And trade is entirely, it's transactional. You have to give something in return. So we see DOT inevitably moving out of the ecosystem. I mean, not everything, but a significant chunk, as people try to see what they can do with their capital on all these different ecosystems. And of course, more people will be curious and be like, well, what can we explore in the Polkadot ecosystem? And through integrations with our parachain, other parachains on the Polkadot network and on the Kusama network would be able to receive liquidity from all of these different chains. So that's kind of the initial plans for Gateway and Hyperbridge as well. I think once we have stable liquidity flows, we can start to think about integrating natively with other L1s and maybe even custom built L1s like the Gear Network and Vara and all of these different Cosmos chains as well. This, of course, is on our roadmap. We're not maxis. We believe that interoperability is it's going to be very, very critical for the entire ecosystem going forward. So I'm going to open it up, of course, at this point. If anyone has any questions that they want to ask the team, I can bring you up and you can share. You just have to request. Mar, you have the floor.
Yeah, no, yeah, hi. I hope everyone is doing great. I have a question because I've been an investor for some time already in cryptocurrency, but lately it's when I've been learning more about the tech and learning more what a blockchain is. I know that sounds crazy that I've been successful in investing, but I, for me, I think I'll be better investor if I learn more about the tech. Now, this Hyperbridge is because the fear of many of the folks that I'm are involved with in crypto, it's bridging because of a third party collecting the fees first and then distribute them, and that's when there's an issue of like at least stories of that third party getting hacked. Is this? I mean, is this as close as what they call out there an atomic swap, where there's no middleman? Uh, and is this project also going to have a coin or not? Those are my questions.
Right. So I think it's a very good question. It's a very good question. So the atomic swap is a protocol where you completely, disintermediate any sort of middleman and you leverage cryptographic proofs that allow you to escrow tokens on one end and then be able to redeem, prove that you've escrowed these tokens and redeem someone else's tokens on the other end, right? That's basically what an atomic swap is, but that's how it's marketed as. Yes, so Gateway actually will also feature this sort of atomic swap model. We don't really call it, an atomic swap. It's not that dramatic. It's basically a token swap. Previously, people would bridge products would have, maybe it's VCs or maybe it's community lock up tokens on a pool, a centralized pool, and it has the rights, the permissions to withdraw from this pool. And of course, as you can imagine, this is also what causes when bridge hacks happen that all of the money in this pool is basically gone and it's now the attackers. Um, in our model, we actually don't do any kind of liquidity pools of any kind because our model is fully trustless, and we can verify that through cryptographic proofs, as in an atomic swap. We can verify that you've escrowed tokens on the one end. We can then permit anyone, and we call these specific people, or this specific set of people, relayers, and they're running some software off chain. They observe that these proofs are now available, and you've indeed locked your assets, and they can opt to give you the liquidity that you need on the destination chain, on the chain that you want this liquidity. Of course, they will do this and also take a portion of the assets for themselves as a fee, because liquidity isn't free. And in this way, basically, you've swapped your tokens. You've giving up, because I think at the end of the day, any liquidity that is native to a chain ultimately cannot be moved, right? It's maybe some bridges might give you a wrapped asset, a wrapped version of that asset, but that liquidity still exists on the source chain, right? It doesn't go anywhere. And so what we're now facilitating in this model is instead you swap it with someone else who has that liquidity on the destination chain. In this case, that person would be a relayer. And anyone can run a relayer. You can run a relayer. This model ensures that there's no centralized pools. That all of your funds are always held by you. You're always custodying your funds. And if someone's requests or someone's transactions eventually becomes finalized, you can basically provide liquidity for this person, and you can be guaranteed that you will always get back their funds on the source chain. And then of course you might be able to then rebalance your portfolio on kind of off protocol, however you like. So I guess that answers that. On the second question, yes, we do have a token. The details of this, we've already discussed this on our blog. I can maybe add that tweet to this space, and you can read up on this later on.
Yeah, and that would be I'll be interested in that. And one last thing, because I overheard right when I got on the space that you guys are going to work with even small like startup blockchains.
Yes, we want to connect as many chains as possible. Our only requirement is that this chain should have sufficient crypto economic security. And what that really means is that there should be enough money at stake that's securing this blockchain. And in this way, we can trust that they will not be malicious.
Okay. Even a proof of work chain?
Proof of work is a bit tricky because, proof of work requires, I would say, a lot of hash power, right? Unlike proof of stake, where it's entirely backed by funds, proof of work has to be backed by hash power. Unfortunately, the only other chain that has, significant hash power would be the Bitcoin network.
Right.
Which is not really possible to bridge to the Bitcoin network because of its lack of programmability.
Right. No, you're right about that. That's why I asked something. But yeah, thank you. And give me that info also to see if I decide to invest here. But yeah, thank you very much, man.
You're welcome. So I think we have Nero as well. You can go ahead.
Thank you. Thank you guys for the work that you're doing. Obviously, I've been following your journey around the Polkadot ecosystem. My question was it's slightly more technical as to I just want to understand the difference between the bridge that we use in the Polkadot ecosystem as compared to the bridges that are looking outward, whether it's Hyperbridge or I don't know if it's the same or to a great extent Snowbridge. If you can touch on that. I just want to understand. I think from your explanation, I understand a little bit from how you explain Hyperbridge, where you can escrow the token and it's can unlock from the other side. Does it differ as far as XCM? Do you transfer token directly? So which means if I have a token, I XCM it to you, the token disappear and it's directly appear on your side, or does the escrow works the same as well, as in it's locked and then reappear?
Right, that's a very good question. And maybe I can also dive in a bit further for the people who aren't very familiar with XCM. So XCM actually is at the application layer of bridges in general. The reason why power chains can communicate almost instantly is because they're all connected to the Polkadot relay chain, the Polkadot blockchain. And the Polkadot blockchain is acting sort of as a co-processor for these power chains. it's validating that they're doing the correct thing, basically. And once it checks that they're doing the correct thing, it can make their latest state available to all the other parachains that it's connected to, in a sense, in this very, very abstract sense. And so if in a block you wanted to transfer an asset from one parachain to the other parachain, what's actually going to happen is you're going to perform a reserve transfer, or a limited reserve transfer, for those of us who have done some XCM, degenning in our own time. And what's happening is that actually that asset is also not going anywhere. It's the Polkadot relay chain needs to track which parachain has which assets. And so what happens is it will escrow the asset on the relay on the parachain's sovereign account on the relay chain. I don't know if this makes sense, but every parachain also has an account on the relay chain.
Yeah.
And then it will send an instruction to the destination parachain and tell it, okay, you can safely mint these assets because I am now custodying these assets on your behalf. And the reason it's done this way is because parachains actually they can't trust each other. A parachain might receive some assets and instead direct it to someone else's account. Like this, it has the power to do this. And so by instead having the relay chain be the central authority for assets, in this way we can mitigate any of these issues. But at the same time, there's also a teleport operation that you can do between, say, system chains and the relay chain. In the teleport, this is where you actually destroy the asset. It's completely deleted on the destination. Its memory is completely gone, and then it's sort of conjured on the destination chain. And so that's the teleport mechanism. So in Gateway and in general, I guess bridges that are outward facing, they also have these same two mechanics. Say I wanted to transfer an asset that actually already exists on two different chains. Say I had some USDC and I'm on maybe Arbitrum and I want to send that USDC to Optimism. Optimism also already has its own notion, right, of USDC. In this case, I will have to do this sort of limited reserve transfer, right? Because I'm escrowing the asset on Arbitrum, and then someone will give me that asset on Optimism. In the case where the asset does not exist on the destination chain, maybe the destination chain has no notion of what USDC is, then it becomes possible to sort of create this synthetic version, this wrapped version of the asset that can always still be redeemed for the underlying asset on the source chain.
Okay.
Hopefully this makes sense.
Yeah, that makes sense. Thank you. I think it's obviously it's the idea of escrow, but it's about how trusted is your escrow.
Fair. So I can also dive a bit more into the mechanics of this, the security of the message passing, right? Because we've talked about, the message and application layer, and now we can talk about how the messages are secured. In the context of Polkadot and, its parachains, all of the messages are secured by the relay chain. This is pretty standard stuff. But in the context of Gateway, Gateway leverages what we call consensus proofs of blockchains. So blockchains, modern day blockchains, proof of stake blockchains, they have an authority set, a validator set, right? And these validators, it's not just a fancy name. Yes, they produce blocks as a result of being in the set, but at the same time, they also vote on what is the canonical chain, what is the canonical sequence of blocks, where in proof of work, this would just be as a result of what is the longest chain in general, right? But in proof of stake, it would actually be what is the chain that was voted on by the validator set. And so if you can obtain what is the signatures, right? Because when we say vote, we mean that they sign, kind of like a transaction. They sign what is the sequence of blocks that should be finalized. And so if you can obtain these signatures, then you can also be convinced of what is the current finalized block in the chain. Actually, really, you can be convinced of the entire chain, right? Because each block points to the previous block, and in this way, it forms a chain. And so, if you obtain this block, and now you know what is the current finalized state, then you can now start to do things like reading what is the state at the current block, right? I can read, say, in a very, very primitive application space, we can have a protocol that says if you transfer some money to the zero account, right? I will give you some tokens on the destination chain. So if I read the state of the blockchain and when I read the state of the blockchain and I read the state of the zero account and I see your transfer there, and this state reading is all powered by proofs as well, Merkle proofs. Broadly, we call them Merkle-Patricia proofs. I can then authorize minting of the asset on the destination chain. So in this way, I've done two-step verification, right? I did the verification of consensus and I did the verification of state proofs. And this really is how full nodes work today. When you run a full node, the full node will obtain these finality proofs, and that's how it knows what is the final block, because it's doing all the signature verification. But maybe the only difference is the full node actually has access to the full state. It doesn't really need state proofs. But a light client, or as we call them, a consensus client, just needs only the Merkle proofs of state. And if it verifies that these Merkle proofs are correct, then we can use that as authorization to mint assets. So there is no traditional intermediary or traditional middleman here. It's just proofs everywhere. And that's why Gateway is, in our opinion, one of the most secure bridges ever built. Hopefully that makes sense.
Yeah, no, thank you.
Right. If there's, we're kind of in the middle of an sort of question and answer session. So if you're just joining, feel free to ask your burning questions that you've always wanted to ask. I think we had one person come up, but they kind of left. So I guess we can just kind of continue. Right. If there's no questions, then I can also keep ranting. So I'm very excited. One of the things I'm personally excited about as one of the applications of Gateway is cross-chain governance. This might not make a lot of sense, but we're now starting to see a lot of applications that are deployed across multiple chains. Famously, Uniswap now is now deployed across all of the L2s and across all of the all these different alt L1s, Polygon and the like, and even Binance Smart Chain. That's good. But all of this kind of creates a problem, right? Like in Polkadot, we're very used to, or we're very spoiled with our on-chain governance tools. These things just don't exist anywhere else. So if you wanted to, say, turn on a fee switch for Uniswap, right, they would have to have multi-sigs for this across all of their different deployments. This, of course, in our opinion, is very risky to have this sort of multi-sigs for all these applications. And so applications can instead opt to have governance on either our chain or on their chain on a sort of single chain, and then trigger a governance action to be broadcasted to all of their deployments across all of the different chains. And in this way, they can securely update their protocol parameters, fully secured by consensus proofs and all these cryptographic proofs of interoperability. And this is, of course, more secure than a multi-sig or a privileged party that has access to do these things. We just had a few people come up to ask questions, so I'm going to give them the floor. Cozy Jihad, you have the floor.
Yeah, beautiful. So this might be a bit of a strange question, but as far as I'm aware, there's sort of two real properties with roll-ups. One of them being that you inherit some level of security, similar to merge mining, but you also have much stronger guarantees, pretty much the same security as the base layer. And then the other property being the sort of data availability zone idea. I think Celestia has written quite a bit about it, but Vitalik also wrote about the idea that you're protected against 51% attacks. Because if there's a reorg, if you've got two chains, just one chain and a side chain, and there's a reorg on the base chain or like the significant cultural chain, then you don't really have any protection after you've bridged your assets across. Whereas I'm under the impression that with rollups, you do sort of have that reorg protection in the same way that, like, if you use an AMM, you're sort of protected from reorgs, in the sense like you put in an asset and now that asset gets swapped to another one. In the event of a reorg, you at least get a state that you had previously consented to, essentially, if that makes some sense. So my question is, do sovereign rollups that are using a data availability base layer get that sort of protection? I'm not sure if that quite makes sense. But does sovereign rollups have any extra protection than a sidechain does, given that they don't really have a bridge?
All right, it's a very interesting question. I'm honestly also not very sure how to answer it. I'm still, reading up on sovereign rollups and this idea that you can basically use a data availability layer as sort of implicit consensus, but at the same time you can really just post any kind of data you want there. There's no checks on the blocks that you're committing. I think that if you wanted to bridge to a sovereign rollup, like you call it, it's not really sovereign because it still has to follow the consensus of its underlying data layer, right? And in this case, its blocks are then ordered by the underlying data layer. And so in that way, it does have some reorg protection as long as the underlying data layer doesn't reorg. I don't know if that answers your question.
Yeah, no, that makes sense. Beautiful.
I think just another question for me. Sorry, I forgot this question. I think the holy grail of Bridge is obviously not just token, but we're looking at NFT transfer. I want to understand from kind of the Hyperbridge perspective, will it be possible to transfer NFTs from one chain to another?
Right. So this is also another good question. As I stated earlier, Hyperbridge is very, very at this very high level, just generic message passing, right? They call it general message passing. This is universal message passing. This is one of the words that's used in the industry. And what that means is you can send any kind of messages through Hyperbridge, whether it's a message to give people assets or mint an asset on the destination. That's how. But at the same time, yeah, you could also send NFT metadata around using Hyperbridge. It's kind of fully permissionless in what you can build on Hyperbridge. You can send NFT metadata. You can even send the NFT itself. You can just have the entire JPEG image as a blob. Of course, this will be very expensive, but I welcome you to do this because this is how Hyperbridge earns its fees. It charges the applications. Or maybe it's more accurate to say the users that use applications that use Hyperbridge, and it charges them on a per byte basis, right? So we're counting the number of bytes that's in your message and sort of giving you a bill according to that sort of message weight. And so as long as you pay the fee, Hyperbridge will deliver whatever it is you want delivered to its destination chain.
Thank you.
All right, Timmy Torpe, please, you have the floor.
I'm sorry, can I get skipped? I'm not ready to ask yet. Apologies.
All right, no problem. That's fine too. I can keep ranting, of course, about some of the stuff that we're excited about. So I think one of the most important things, and this is kind of sort of in relation to some of my recent tweets, is that eventually users are not going to care about what exactly it is they're using. They just want some action done, right? and they will use what are the reasonable defaults for that action. Say for instance, I have swaps integrated into Nova Wallet, right? I'm not really like, my money's already on Nova Wallet, right? I'm not really going to like open up this esoteric website just so that I can use, I can connect my Nova Wallet and I can use swaps on this wallet. When Nova Wallet itself already provides sort of a swap interface, like it's just right there for me to just use. And so this is why we believe that it's going to be very important that Hyperbridge is integrated into wallets, as many wallets as possible. And this is going to be, part of our more short-term plans, of course, once we launch the bridge and, allow for dot bridging. And this, we believe, will drive more users in general to Hyperbridge. There's some time delay in when you bridge on Hyperbridge, because we have to wait for all this finality and all of these proofs. And I'm seeing people around the industry say like, oh no one wants to wait. Actually, I completely disagree. I disagree. The reason I disagree is people already wait. They wait for bank transfers, right? They understand that things cannot be instant. And especially in a case where you're now working with fully permissionless systems. And for instance, when you bridge, or rather when you deposit, say, tokens from Ethereum, you deposit tokens from any chain. But let's just use Ethereum as an example. Say you deposit tokens from Ethereum into your Binance account. Even Binance has to wait, right? They wait for finality. They wait for confirmation of your transactions. They're not just going to be like, okay, yeah, no, we believe you. You can start trading immediately. No one does that. And so bridges are also inevitably going to be as slow as the underlying consensus system that is hosting the message. And more importantly, I think that this will bring back to mind the fact that we are using blockchains. We're not using servers. It's if you're using a server, that's when things are kind of instantaneous. But blockchains are very asynchronous in the way that they achieve finality and in the way that they confirm transactions. We all know this, but somehow bridges don't reflect this, and people are now trying to go in this wrong direction that we should completely bypass this confirmation logic, this confirmation rule. This can only result, in my opinion, in exploits. Any bridge that's going to be secure into the future will obey the laws of the land, in this sort of colloquial sense. So that's kind of my own opinion on how users will interact with bridges. Users will understand inevitably that yes, Ethereum has. I mean, if you're using Ethereum and you don't understand that Ethereum has slow finality, then you must be living under a rock, because everyone knows this at this point. All right. And if you're, of course, using rollups that are on Ethereum, then this is inevitably the case as well. If you're using networks like Binance, if you're using networks like, I guess, any of the alt L1s that have faster finality, then when you of course send your tokens, you deposit your tokens into an exchange, and then you kind of see how fast the confirmation is. This kind of gives you this kind of programs you subconsciously that this network must have fast finality, and you will experience the same thing when you're bridging on Hyperbridge or you're bridging on Gateway. But it's going to be different, of course, like I said, for networks like Ethereum. When you're bridging from a network that has fast finality, say from a parachain, meaning parachain users, they're already very used to fast finality within the ecosystem. We will also be able to provide that comparable level of speed, right? Because we're waiting for the parachain block to be finalized, and this happens very quickly. It happens almost instantly, and so you will have fast finality to any chains. But if it's a network that just has slow finality, then you will have slow finality, and it's kind of it's the trade-off that you picked, right? You want your assets to be secured by Ethereum. Well, Ethereum has slow finality, and this is just the trade-off that you've made. So that's kind of my opinion on slow versus fast bridges. There is no such thing. There is no such thing as a fast bridge. There is only fast finality of the connected chains on the bridge. So that's just something I think would be important to keep in mind going forward. Does anyone else have questions? Of course, if you're joining us, this is more of an interactive question and answer session. So if you have any questions for the devs, you have any questions for the team, just do let us know. You can just request to come up and ask your question. We'll be happy to answer. David, is there anything you also want to share as well?
Yeah. So I wanted to talk about the issue of speed versus fast versus slow bridge issue. So now, when like you're bridging, I feel like the issue of like fast bridge and slow bridge is like a psychological response of the user knowing that okay, the bridge is not inherently safe, so I need to like get out quickly. So users generally want to be in and out of the bridge. Like nobody wants to spend a long time on a bridge because they're not really sure of the back end. They don't understand what is happening like underneath. The whole process is opaque and they, they are not sure of the security of their funds basically. So they just want to go in and out. So I feel like once users know how the entire process works, like how we explain the gateway, how uh, they know we're waiting for finality, we are verifying proofs and all. I don't think they'll be so worried about the speed of the of like bridging. So it's if the users have enough control over the full process, the entire process, then I don't think the speed of bridging actually matters at that point. Like people only want bridges to be fast because they are not they don't feel secure with using that platform. So those are my thoughts on fast versus slow bridge.
Yeah, no, very, very good points in my opinion as well. Yeah, no, people inherently distrust bridges. Like, I've lots of people have famously asked me, like, why are you working on a bridge? No one likes bridges. And I agree, yes. And that's why we're working on bridges, so that it can be better. We can't run away from our problems. People are always going to use bridges. Bridges are going to be very important for trade in this sort of abstract sense of the word, right? Because I at the end of the day, it's all just capital. It's all capital, and it's inevitable that you have capital flights in this sense of the word, right? You want to look for better opportunities for your capital, like I was just describing earlier with having people be able to lend against their dot in places in chains that just have more liquidity. People are going to want to look for better opportunities elsewhere. I might be on Solana because of the whole degen craze. And now sort of the degen craze is over. There's no more money to be made. I need to go somewhere else where there's money to be made, right? I need to use a bridge. I wouldn't want to have to use a centralized exchange as a bridge, right? This just means I have to start to do very lengthy KYC processes. God forbid the exchange goes down while they're custodying my funds, as has been the case in this industry, right? So yeah, bridges are inevitable. They're inevitably going to be part of the future of crypto, and um, it's time we made them better, in my opinion. So we have I can't really pronounce your name. I'm sorry, Lukamba. Please go ahead.
Yeah. So hey, soon, and hey, everyone. So I guess I'm pretty sure. You can call it Lucamba. It's okay. One thing is concerning the security of Hyperbridge, as the security is derived as all the state commitment are done in the parachain, and the parachain is secured by the relay chain, and that's why you're deriving all the security on top of that. And I just want to understand, because Tesseract is closed source, so don't try to make sense as in the relayers like take the state stored in the Hyperbridge node and work upon that, right? Like just on top of my head, like thinking about the architecture. And also there's this tool on like if your funds are stuck, you can prove and then like get your funds back. And I just want to more understand on that. I want to more understand on that, like is it like you're proving okay, because one thing is you submit your intent to breach, so it means that intent will be stored in the chain, and then if the relayer like fails to execute it, now you can like remove your intent commitment from the node, or how actually does it work in that sense?
Yeah, no, that's a very good question as well. So, I mean, you can call it intents, we call it requests, but at this abstract level, they're kind of the same thing. So how it works is, and this is maybe you might be um, bordering a little bit on the technical details of ISMP is that when you initiate a request, that request is actually stored in the state of the blockchain. It's kind of like your balance, right? Your balance of your account is stored in the state of the blockchain. We call it the state. It's this key value store that's in the blockchain, and this state is actually Merkleized. And what that means is we create a commitment to that state at every block. If you've ever seen maybe an explorer, you might see in a block metadata, you might see what they call the state root. And this is that commitment to the entire state. In Hyperbridge, we call it the state commitment, like you said. And so in the state commitment, using state proofs, we can basically read the entire chain. We can ask for whatever key in the state and ask for its value, so to speak. And someone just provides us with proofs of that, and we verify the proofs and we see the value. All good. So when you're sort of initiating a cross-chain transaction, what inevitably happens is that eventually our state commitment, the state commitment of Hyperbridge, will get to the destination chain. And then once the state commitment is on the destination chain, a relayer is actually going to submit the proofs, right? This state proofs that reveal the request that you made to the destination chain. Now, if the destination chain hasn't seen this request before, and if this request has not timed out, then it will execute this request. It will basically hand over the request to the destination contract or the destination pallet or module, whatever the case may be. And so in this case, once the module executes the request successfully, then we store that request in the destination chain's state. Now, this is very important because this enables two things. This enables the relayers to be able to say to Hyperbridge that, hey, look at this destination chain's state. I was the one who delivered this request, and so I am now eligible to get the funds that were used, that were locked up to be used for the request delivery. And that's one of the things it enables. The other thing it enables is that if the request times out and it's of course no longer able to be delivered to the destination chain, because even if you try, the destination chain will just reject it and say that this is a timed out request, it's now invalid. It's kind of like the mortality field in transactions in substrate extrinsics. And so what will happen is you can now say as a user to Hyperbridge, look at the destination chain's state. They have not received my transaction, and that transaction has now timed out. And you prove this, of course, using state proofs. And this then allows you to basically get your money back out of Hyperbridge, because the way that the module is configured is if you get a timeout, then the module will just give you back your funds. And it can do this because the only thing that can trigger this action is cryptographic proofs, and you can never forge these proofs. There's like hard cryptographic guarantees about hashing and about signature verification. So this is impossible for even North Korea to crack. And this is how we're able to safely allow you get your funds back. So it's never going to be the case that you actually have successfully redeemed the asset on the destination chain and then still get the asset back on the source chain. That's just never going to happen. Hopefully this makes sense.
Yeah, it does. Yeah, thank you. Yeah.
Right. So we're nearing the 1 hour mark. I think we have time for just maybe one last question before we wrap up this space.
Yeah, I guess no one is asking, so let me just go on and ask one more question. Okay.
Go ahead.
So we, as we know, like everything's like the speed of the bridge like depends on the underlying consensus speed, right? It's all known. But the issue is if Ethereum goes into, for example, into using stateless clients, right? So it means like there'll be division like stateless client and stateful client, of one for like data posting and one for only verification of everything. One thing is how will Hyperbridge evolve into that? And for that case, can it be like optimistically speaking, can it actually even reduce the latency for bridging in that sense?
Right. So maybe to answer the first question about stateless clients, the whole stateless clients thing. Personally, I don't know how this helps the network, but basically means that blocks can now be gossiped on the network alongside the, well, we call it a block witness, right? This witness just contains all of the parts of the state that were accessed by transactions in the block that were accessed, during the execution of transactions in the block. This just means that nodes no longer have to have the full Ethereum state. Well, I guess it does help the network because the Ethereum full state right now is about two terabytes, which is it's actually a ridiculous number. But this doesn't actually affect Hyperbridge in any way. We can always access what is state proofs of parts of the state that we're interested in. So this doesn't change anything. To answer the question, how can we get faster finality or how can we get faster bridging from Ethereum, right? Because that's just the only problem here is that your state machines, both the execution layer and both the L2s that are on Ethereum are kind of bottlenecked by its consensus. And so if anything is leaving Ethereum, then they have to take 20 minutes to confirm. And so the way we can get faster bridging from Ethereum and its ecosystem is if they implement what they call the single slot finality. I personally don't know how this is going to work, but the promise of it is that we will now get finality proofs for every single Ethereum block. It will not be for 2 epochs past, because that's kind of what's happening right now. Once let's say from the perspective of a current block, it will only be finalized after 2 epochs. And this is kind of the Casper FFG voting mechanic. And yeah, this makes sense because there's just so many nodes on the network that trying to vote on a single block is just impossible. Which is why I said I'm not sure how they're going to make this happen, but we'll see. Right,
Yeah,
Jimmy.
I think, yeah.
Yeah, Lukamba, you can give us your closing thoughts.
Okay. Yeah. My closing thought is, as I just said, like Ethereum, finality, like it finalizes after every 2 epoch, right? So it means like it's kind of like how Grandpa, like if Grandpa finalizes block 30, it means blocks below 30, all of them are finalized, right? So it means even in the case of Hyperbridge, like not all the time will a person have to wait for like 10 minutes, because for example, if like the second epoch at which the finality occurs, it's where you actually transferred, you actually breach your funds. It means you will get, like, the user will experience much less time to finality as the funds were breached in a block whereby it is near the finality slot. If I'm clear on explaining that.
Yeah,
Like,
no, basically.
yeah. Yeah.
Yeah, so yeah, basically, users that are on networks with faster finality will experience faster bridging to any of the networks that they want, that they're trying to bridge to. And you can already see an example of this if you try out Gateway and you use the BSC network and you select the BSC network as the network you want to send from. You will experience finality less than, I think, 2 minutes at the worst case. Jimmy, you can go ahead.
Yeah, thank you, Sean. You mentioned I want to refer to your previous response, because you mentioned that the requests can like can be timed out. So my question will be, what is the, like, under what conditions the request can be timed out, and also about the proofs you mentioned. are the proofs based on the ZK proofs, or this is some other methods?
Yeah, for sure. So first off, users, when they're interacting with a contract or a module or a palette, whatever it is, that will initiate a request. These modules ideally should allow the users to configure the request timeout value. So for instance, in Gateway, there's actually a small button at the top. If you click it, you can see, you can sort of configure your request timeout. And then this way, users are actually in control of how long they want to wait for. You know, if it's the case that they're going to have to wait a long time, then they will just, the request will just time out, and then they will just get their funds back. On the topic of the proofs, so the proofs that are used for requests, actually it's a combination of two different types of proofs. We use both a Merkle mountain range, and this is used in the happy path, in the optimistic sense that a request is able to be delivered. Then you use a Merkle mountain range to confirm that it was actually initialized, or it was actually initiated from Hyperbridge and the Hyperbridge node. In the failure case that the request was unable to be delivered, then you use a Merkle-Patricia proof, which the Merkle-Patricia trie is the sort of architecture for blockchain state in general. And you basically give us a proof, a Merkle-Patricia proof, that says that your request was unable to be delivered, and even though the request is now timed out. So those are the two proofs that we use for Hyperbridge.
Okay, thank you very much.
Yeah, I mean, I would also say that you want to be very, very careful with people who just use the word ZK and they throw ZK everywhere. Not a lot of things are actually possible in ZK. And this is especially the case when you look at how frequently, these ZK L2s on Ethereum post proofs. Computing ZK proofs is super expensive. It takes up a lot of power, takes up a lot of compute resources. And so trying to ZK prove every single cross-chain message is just not going to scale. I can tell you right now, unless of course, maybe the users are computing these proofs, but then that also means that they have to wait a while for them to generate their own proofs. And so we believe that just using stuff that doesn't require expensive proving, like Merkle proofs and Merkle-Patricia proofs, this stuff is very accessible and they're very secure. There's, if you're going to put a Merkle-Patricia proof inside of a ZK proof, then you're still using a Merkle-Patricia proof at the end of the day. So that doesn't really add anything, doesn't add any layer of security. It's still the same level of security. And so it's fine to just do this and do this on chain and just make them cheap to do. All right, so I think we've now come to the end of the session, end of the AMA. We will be having some more updates, relating to Hyperbridge in the coming weeks. The next steps for us right now is to do audits. We are in contact with the SR Labs team. SR Labs is the team that's responsible for auditing Polkadot and Substrate and all of the associated system chains that run on the Polkadot network. So we believe that we are in safe hands here. Once audits are completed, I think we will be also waiting for Beefy to go live, but I know that there's already a governance motion to just activate Beefy and squeeze the validators that are not they've not been activated out of the active set. I'm here for the violence, so we'll see how that goes. And that, those will just be the only things left for us to basically go live and start off with letting people bridge their DOT and bridge, their parachain assets to different chains and sort of open up the Polkadot ecosystem to the world in this sense. So, we're looking forward to this. We believe that this is it's going to be exciting times for sure, and we can't wait to have you guys with us on this journey as well. So, thank you. All right, guys. Have a good one and take care.
Yeah, thank you for joining.